Welcome to The Explainer. Today we've got a story for you that is, well, it's one of the most incredible survival stories in the entire history of science. It's a story that, by all accounts, just shouldn't be possible.
So let's just dive right in. The year is 1978. A 36-year-old Soviet physicist, Anatoli Bugorski, makes a catastrophic mistake. He puts his head directly into the path of a high-energy proton beam. What happened next just defies all logic.
The beam that hit him carried a dose of radiation hundreds of times beyond what is considered lethal. So the big question we're going to try to answer today is pretty simple, but it's also incredibly profound. How in the world is he still alive?
To really get our heads around what happened here, we have to start with the numbers. And honestly, they are just mind-boggling.
Okay, here's the number that matters most. A dose of just 5 grays of radiation to your whole body is fatal for pretty much anyone. Bugorski's head absorbed up to 3,000 grays. Let me say that again, 3,000. That is 600 times the dose that should have killed him on the spot. And yet, it did. So let's go back in time to that fateful day, July 13th, 1978. We are deep inside a top-secret Soviet science city, right at the peak of the Cold War's race for scientific supremacy.
The whole incident went down at the U-70 synchrotron. Now, at the time, this thing was an absolute beast, the most powerful machine of its kind anywhere on the planet. And its job? To take tiny protons and accelerate them to 76 giga-electron volts, which is just a hair's breadth shy of the speed of light.
Bugorski, who was just there to check on a piece of malfunctioning equipment, walked straight into a trap. It was a literal perfect storm of failures. The main safety systems were turned off, the mechanical door lock was busted, and, this is the real kicker, the warning light that should have been screaming, "Danger! Beam is on!" had burned out. He had no idea it was active.
So he leans over the machine, and in an instant, the proton beam shoots right through the back of his head and comes out his nose. He later said he saw this brilliant flash of light, but in that moment, he felt nothing. Absolutely no pain.
And what's truly unbelievable is what he did next. He didn't panic. He didn't even stop working. He just finished his tasks for the day, went home, and didn't tell a single soul. It was only the next morning, when the left side of his face had swollen up so badly he was unrecognizable, that he finally went for help. He was rushed to a special clinic in Moscow, where the doctors basically prepared to watch him die.
So yeah, everyone expected him to be dead within days. What did they all miss? Well, the answer isn't really in biology, it's in the incredibly bizarre physics of the accident itself.
This chart really shows you the core paradox, right? A dose of 3,000 grays is unthinkable. It should be completely incompatible with life. His survival hinges entirely on how that dose was delivered, in a way that just defied everything doctors knew about radiobiology at the time.
Okay, so here's the first major key to his survival. See, unlike the radiation from something like a nuclear bomb, which spreads out and fries your whole body, destroying your bone marrow and organs, this proton beam was incredibly focused. You got to think of it like a microscopic, super hot needle, not a bomb. It passed through his head in one tiny, narrow track, and that's what spared the rest of him from a fatal dose.
And then there's this second key, which is this really fascinating, kind of weird phenomenon in physics called the Bragg peak. The simple way to think about it is this. As particles like protons travel through something, like, say, a human skull, they actually dump more and more of their energy right at the very end of their journey. It means the beam got even more destructive just as it was about to leave his head.
And you can see that effect right here in the data. The beam went into the back of his head with a dose of 2,000 grays. But by the time it shot out his nostril, the dose had ramped up to 3,000 grays. This incredibly localized, focused, and escalating energy deposit is what made the injury survivable, but also so damaging to everything in its direct path.
But surviving the unsurvivable, well, that doesn't come for free. The proton beam may have spared his life, but it absolutely changed it forever.
I mean, this beam just carved a precise line of destruction right through his brain. It entered his occipital lobe, that's the part that handles vision, which is what caused that brighter than 1,000 suns flash of light. It completely destroyed the inner structures of his left ear, leaving him deaf on that side for life, and then it severed his facial nerve, which instantly paralyzed the entire left side of his face.
The scar tissue that formed in his brain later caused him to develop epilepsy. He suffered from intense mental fatigue for the rest of his life. And yet, almost unbelievably, Because that beam was so incredibly narrow, his core intellect, his ability to think, to reason, to function as a brilliant physicist, remained completely intact.
In fact, his resilience was just staggering. After about 18 months of recovery, he didn't just go back to an office job. He went back to the very same institute, continued his research in physics, and successfully defended his PhD. He even became the coordinator of physics experiments there for decades to come.
But now we get to what might be the single most bizarre, most visually striking long-term effect of this entire story.
So, decades after the accident, something very strange became obvious. While the right side of Bugorski's face aged normally, it got wrinkles, it sagged a bit, the left side, the side hit by the beam, remained almost perfectly smooth. It was as if it was frozen in 1978. The leading theory is pretty straightforward. The paralysis meant the muscles never moved, so they never formed wrinkles, a permanent, if completely unintentional, Botox effect.
Ultimately, Bugorski's story is so much more than just a medical curiosity. This 1 in 8 billion accident gave us profound, if unintentional, insights into how the brain responds to extreme trauma. It's even helped inform modern medical treatments like proton therapy for cancer, which uses the same idea of focused radiation. But it really leaves us with this huge question. What else don't we know about the incredible, almost unbelievable endurance of the human body?